Hi and Assalamualaikum. So today we are going to present our group project which is draft a bench vice assembly. So our course code is BNP 10403 and our course name is Engineering Drawing and CAD. So we are from group 1 and our lecturer name is Madam Salina binti Sani. But first, let me introduce you my group mate during our project. So the first one is myself, which is Ashraf bin Rashid, and my matrix number is CN240124. And second is Chan Enyong. His matrix number is AN240014. The third member is Muhammad Afiq Ifan bin Nasaruddin. His metric number is CN240038, and the lastly is Muhammad Najmi Hakim bin Risham. His number matrix is CN230148. Okay, now I'm going to show you about our introduction. So, there is three main point in the overview, which is the first one is project goals, second is key objective, and thirdly is outcome. So, our project goal is to teaching student practical AutoCAD skills by designing a bench vice assembly. So, for the key objective, to create a functional vice grip used in tasks which is such as welding, assembling, and maintenance. And thirdly, about outcome, which is to learn technical drawing and CAD modeling, essential for engineering application. So, there is too many objectives for this task, but I only presenting you 3 points, which is the first one is developing CAD skill. So, it is to use AutoCAD create 2D and 3D model of a vice grip, improving drawing skill and software knowledge. So the second objective is work teamwork. So which is work as team to share ideas, divide tasks and combine effort into one project. And maybe next point is improve communication by discussing design and giving feedback. So the last one is component drawing, which is draw detailed part of the vice grip like jaws, handle, screw, and the locking mechanism, and it is to ensure correct dimension, material, and assembly detail.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Irfan bin Nasaruddin and my matric number is CN240038. Today I will be discussing our methodology tools today. As you can see, three tools were employed and the AutoCAD comes first. Autodesk AutoCAD 2018 and Autodesk AutoCAD 2015 were involved in this project. And then the Tinkercads come next. And lastly is the Fusion 316. I will describe the process that we employ in AutoCAD 2018 and 2025. For your knowledge, one of our group members were using AutoCAD 2018. Thus, we utilize AutoCAD 2025. Our organization primarily use AutoCAD 2025, although one of us prefers AutoCAD 2018. Firstly, we use AutoCAD to create a 2D drawing of our project, which is a bench vice. We split up the 2D drawing among the members, and next we use AutoCAD to complete all of the drawings, including the title block and the 3D. This is include for the finishes. Next is Tinkercad. As you aware, Autodesk also includes Tinkercad. It is available on the internet. Tinkercad is used to build our 3D assembly and exploded view drawings. We have to save the drawing in STL format after creating the 3D. This is because we have to convert it to DWG format for the AutoCAD finisher, which is a somewhat time-consuming procedure. This will add originality and creativity to our assembly. Next is Fusion 316. We need to turn the mesh into a solid after importing the STL file from the Tinkercad. The 3D assembly won't show up in Autocad if we don't do it. Next, we use the Mesh Smooth, Mesh Refine and Mesh Edit tools to clean and adjust the assembly. The assembly is then exported in DW format.
Hi everyone, my name is Chan Eun Yong and my matrix number is AN240014. Now I'm going to talk about the components in our drawing. First, the component is spacer. We have used two quantity in this and the materials is steel MB1020. First, we have draw 2D for the spacer and we convert into 3D, and this is much more easier for us to convert because we have do the 2D drawing then can convert to 3D. The function of spacer is first alignment and separation, second load distribution, third smooth movement, fourth prevention of over tightening, fifth compensation for manufacturing tolerance. Then the orthographic drawing, we have used third angle for this. The second components we have used in our drawing is handle. We have used one quantity for this and the materials is steel MB1020. We have also draw 2D and 3D for this. First we draw 2D, then so more easy for us to convert to 3D. Then the function of the handle is first operation control, second mechanical advantage, third adjustment, fourth safety and ergonomics. Then for the orthographic drawing, we have also used the third angle for this. The third component we've used in our drawing is screw. We have used one quantity in this and the materials is steel MB1020. First, we have draw the 2D picture of screw, then we convert the 2D into 3D screw. Then the function of screw is first clamping mechanism, second force multiplication, third precision adjustment, fourth durability and strength, fifth is locking ability. Then for the orthographic drawing, we have used the third angle in this. The fourth component we use in our drawing is body. We have used one quantity of body in this. Then the materials is forged steel MB1020. We have drawn the 2D drawing of the body. The 2D have two drawing in this. First is the main, which is body. Then the second one is the details. Then we have convert this into the 3D drawing. Then the function of the body is first structure support, second durability and strength, third jaw alignment, fourth mounting base, then the fifth is guidance for moving parts. Then for the orthography drawing, we have used the third angle in this.
For this part, I will explain a little bit about the jaw. There are a few functions for the jaw. First one is clamping and holding items. Next, for even pressure distribution, alignment, and adjustability. Outside of it, we have an orthographic drawing that shows the view from front, side, and the top of the components. For this part, this is the assembly drawing of all our components that our group has choose. All this component is this assembly of bench files. There are a few components like my friend have explained earlier, which is jaw, body, screw, spacer, and handle. So now we are at the bill of material part, or we call as BOM part. In this section, we will list down all the quantities for each components that have in this section. First, we have spacer. We have two spacers that are used on these items. The material for this spacer is steel NB1020 with dimension 20 times 10. Next, we have handle. The material for this handle is same as spacer, which is NB1020 with dimension of 8.6 times 130. We have also we also have screw and jaw with its quantity is one only for each items. The dimension of the screw is 22 times 93. The material for the body is forged steel NB1020.
Next, the challenges that we had during the project. The difficulties we encounter while working on the project come next. First, we deal with intricate measurements and drawings that necessitates a high degree of precision and accuracy in the 3D construction, which is the project. Next, we encounter technical difficulties resulting from hardware and software limitations and computer specification constraints, which made it challenging to satisfy our needs in the drawing. After that, we had to make sure the drawings were realistic and appropriately reflected real world skills because it was difficult to maintain appropriate scaling. And lastly, we had issues with Autocad layer organization since there were too many layers added. It will confusing the old layers with the new ones. That's all from me. Thank you.
So this is the last part of the presentation, which is conclusion part. So the bench vise project helps students learn important skill. So we are going to make detailing drawing for part like jaws and handle, and use it AutoCAD 2D and 3D modeling, such as Tinkercad and Fusion 360. So we also solve design problem like improving the locking mechanism, and student create a clear documentation with parts list and assembly instruction, meeting project goals with accurate drawing and complete model. That's all from us. Thank you.